Hello, everybody. Welcome to episode 3 of The Spirit of Apollo. I'm your host, Mark Lesmeister. So, in the last episode, I mentioned the fact that American rockets have been assembled vertically. And I can imagine many of you responded with, well, duh, how else would you assemble a rocket?
The Saturn V rocket was assembled vertically in the Vertical Assembly Building, now known as the Vehicle Assembly Building, at Kennedy Space Center in Florida. In fact, you could build several Saturn V simultaneously in the same building. Once the Saturn V was assembled, then it was brought out on the crawler vehicle shown here and brought to the launch pad to be ready for launch. The Russian Soyuz rockets, on the other hand, were assembled horizontally, and they were brought horizontally to the launch pad and then raised up into the vertical position to be ready for launch.
So, why would a country choose vertical assembly over horizontal assembly or vice versa? Well, consider the fact the other day when I was assembling my rocket and I was holding it like this and trying to put these panels on the bottom, this piece here actually fell off just like that. We can take a look at a concept from physics to see if we can understand why that happened.
To get some appreciation of the differences between assembling rockets horizontally and assembling them vertically, we can use the physics concept of torque. Now, torques are like forces in that torques can cause changes in motion. But while forces cause changes in motion translationally, that is motion from place to place, torques cause things to start rotating or stop rotating or change the speed of their rotation. So let us say that we wanted to take a look at this two-stage rocket here. We have a stage over here on the right and a stage over here on the left. And we wanted to calculate what torque would be exerted on the right-hand stage. Now, to calculate torques, you have to pick a point about which you want to calculate the torque. So we can use this point right here. And let us say we want to know how much torque would be exerted about that axis right there by the forces that act on my right-hand stage. The force we will consider in particular is the force of gravity, which acts straight down as usual. The other thing you have to consider when calculating the torque is what is the distance from where the force of gravity acts, which is right here at its center of gravity, to where you are trying to calculate the torque around. So that would be that distance there. The other rule is, and this is the important thing, you only have to count the force that acts perpendicular to that distance from where you're trying to calculate the torque to where the force is being applied. So in this case, since gravity points straight down and our rocket is lying horizontally, all of the force of gravity contributes to the torque. And if that were the only torque acting, my right-hand stage would start to rotate. Now consider a rocket that we're assembling vertically. We have the same forces acting, the force of gravity acting here, and we have the same line from where we are trying to calculate the torque from to the point where the force of gravity is being applied. But now none of the force of gravity acts perpendicular to the direction from the axis to where the force is being applied, and so no torque is exerted.
So, to sum up, forces along the long axis of your rocket, not a problem. Rockets are made to absorb that. Forces perpendicular to the long axis of the rocket might cause problems. So why would a country choose to build the rockets horizontally? Well, it's probably a lot cheaper because it's simpler, and there are other practical considerations to be made. In any case, since most of the weight of the rocket is the fuel, and since the fuel is not added until the rocket is vertical on the launch pad, the difference between a horizontal assembly and a vertical assembly is not as large as it might seem. So I'm going to assemble, mostly vertically today, bag number 3. I believe it's more external trim for the lower stage of the rocket. So this is what the model looks like after we added bag 3. You can see that the first stage of the Saturn V is really starting to come together and start to look more like the first stage. So until next time, Godspeed.